So integration, that's basically the reverse of differentiation. How hard can it be? So I won't go through a first principles proof for this one because it's quite complicated and something that would usually be covered at degree level maths or physics rather than at A level. So we'll just have a look at an example and how it works. So taking x to the power of n, what we do when we integrate is this is how you notate it. You have the integral symbol and you say integral of x to the power of n dx. So that means I'm integrating x to the power of n with respect to dx. The notation is important. And then what you get out at the end is you add 1 to the power and then you divide by the power. So this is all part of the same step, but it's spread out so that you can see it more clearly. So integration, reverse of differentiation, you add 1 to the power and then divide by the new power. And you always need to remember a plus c at the end because you could be integrating, or you could be differentiating, say, x squared plus c, but when you integrate 2x, then you don't know whether there's going to be a plus c at the end. So because it's the reverse, you need a plus c, because it's you're not certain what the thing you're going to get out at the end is. It's called an indefinite integral. And this only works for when n isn't equal to -1, because you see if n equals -1, so if this is x to the power of -1, then you get a -1 plus 1, which is divided by 0, which causes all kinds of problems and you want to avoid. So if you're integrating with respect to x to the power of -1, you'll do that in A2 if you haven't done it already, and if you're doing a -1 then it becomes a logarithm, and if you haven't done that yet then don't worry about it. So let's do a quick example. So what we want to do is we want to add 1 to each of the powers to make this 4, to make this 3, and this would be times by x to the power of 0, so add 1 to the power, you get x to the power of 1. And in doing so, after that, we then divide by the powers, so divide by 4, divide by 3, and divide by 1, and don't forget the plus c. So if we're doing an area under a curve, one of the main applications of integration, then we'll take this curve here, y equals 3x squared, and just put a few points on it. So if we want to find the area between 5 and 0, then we highlight that area so we know what we're doing. And then we say we're integrating 3x squared dx, and we find out what it integrated is, and we sub in the values at 5 and 0. So a more correct notation of this, I'm not sure why I didn't write it in, is you would have a 5 up here and a 3, and sorry, a 0 down here, so you'd have a 5 at the top, so the larger number that you're integrating, and the lower number would be at the bottom, so the 0, and they're called the boundaries of the integral. Once we've integrated it, we've got 6 times 5 plus c minus 6 times 0 plus c. You'll see because you're subtracting it, the c's cancel out. So when you're doing a integration with boundaries, you can actually completely ignore the plus c, and you can just do the integral to get 6x, ignore the c, and then sub in the numbers after 5 and 0. And in this case, it gives the answer of 30. And if you're doing it between two curves, like this, x squared and x cubed, so the x cubed would obviously carry into 0, carry into the negative quadrant like that, and the x squared would carry on like so. But we're just interested in integrating it between 1 and 0. Now there's two ways of doing this. You can either do the integral of the x squared graph between 1 and 0, and then the integral of the x cubed graph between 1 and 0, and find out the difference, or you can straight away say what I'm going to integrate is x squared minus x cubed, like that. And here we've got the limits of the integration on, and we sub in the numbers, so add 1 to the squared, divide, add 1 to the cubed, and then divide, and sub in the numbers like so. The 0 term goes to 0, these just become third minus a quarter, and that gives us a 12th. So that's the integral between two curves. So whatever the curves are, you've just got to follow that method, plug in the limits of integration to the points where they intersect, and then solve for your answer. So remember, comments if you something you don't understand, and just message me if you want something else covering that you haven't seen in any of the other videos.